Hello everyone. In this project, we built a machine learning system to predict customer churn using the target customer churn dataset. Churn refers to customers uh, who stop using a company's services. Predicting churn is extremely valuable for telecom companies because it allows them to identify at-risk customers and design targeted retention strategies. In addition to building a predictive model, this project focuses on responsible AI principles, including fairness, transparency, and reliability. Therefore, our workflow not only evaluates predictive performance, but also analyzes bias, model calibration, and interpretability using explainable AI techniques such as SHAP, PDP, and LIME. Let's overview the dataset. The dataset contains 7,043 customers and 21 features, including demographic information, service subscriptions, and billing details. The overall churn rate in the dataset is approximately 26.5%, meaning about one quarter of customers leave the service. We also performed some exploratory analysis and found that churn rates vary significantly across contract types and internet services, suggesting that customer-to-contract structure and service quality may play an important role in churn behavior. Before training the predictive model, we conducted anomaly detection using isolation forest to identify unusual customer profiles. About 212 customers were detected as anomalies, representing roughly 3% of the dataset. Interestingly, these anomalies actually had a lower churn rate of about 11.8% compared with approximately 27% for normal customers. This insight is important because it showed that unusual customer behavior does not necessarily mean higher churn risk. In many cases, these anomalies correspond to stable customers with specific service combinations. We compared three classic machine learning models. First one is logistic regression. Second one, random forest. Last one, XGBoost. We use five-fold cross-validation and evaluate performance using accuracy, F1 score, and ROC AUC. Among these models, XGBoost achieved the best validation accuracy of about 0.796 and a validation ROC AUC of approximately 0.836. So we selected that it as the final model. We also optimized the decision threshold rather than using the default value of 0.5. The optimal threshold found on the validation set was 0.485, which improved the balance between precision and recall. After retraining the model on the combined training and validation data, we evaluated it on the test set. The final model achieved The accuracy is 0.798. The precision is 0.643. Recall is 0.54. F1 score is 0.587. And the ROC AUC is 0.843. This confusion metric shows that the model performs well at identifying customers who will stay, while still capturing a meaningful portion of churners. Because churn prediction is an imbalanced classification problem, ROC, AUC, and recall are particularly important metrics. Overall, the model provides a strong balance between predictive performance and interpretability. Responsible AI also requires reliable probability predictions. Therefore, we evaluated model calibration using a calibration curve and the Berea score. The model achieved a Berea score of 0.1368, which indicates reasonably well-calibrated probability estimates. The calibration curve also shows that predicted probabilities are close to the observed frequencies. This is important for business decision-making because retention strategies often depend on predicted churn probabilities. Next, we evaluated fairness across two demographic groups. First one in gender and second one in senior citizen. For gender, the demographic party gap was only about 0.0145, indicating that the model predicts churn at very similar rates for male and female customers. However, the fairness analysis for senior citizens revealed larger differences. The demographic party gap was approximately 0.27, and the equalized odds gap was around 0.21. This does not necessarily mean the model is biased, because the actual churn rate for senior customers is also significantly higher. However, these gaps highlight the importance of monitoring fairness and ensuring that retention campaigns are applied equitably. To understand which features influence churn predictions, we applied SHAP values and permutation importance. The most important features identified by the model include contract type, tenure, online security, fiber internet service, total charges, and total charges. For example, customers on month-to-month contracts and those with shorter tenure tend to have a much higher churn risk. These insights align well with typical telecom industry patterns. Let's see, here is the chart. We also examined individual prediction using SJP waterfall plots and line explanations. For example, in one case, where the model predicted a churn probability of 0.89, the main contributing factors include month-to-month contract, short tenure, high monthly charges. On the other hand, customers predicted to stay typically had long tenure, long-term contracts, and more protection services. These explanations help managers understand why a particular customer is predicted to churn and allow them to design targeted retention actions. Using a model explanations, companies can design several churn prevention strategies. For example, encourage customers to switch from month-to-month contracts to longer-term contracts. Offer discounts or loyalty rewards for customers with short tenure. And last one is promote security and technical support services to increase customer retention. Because the mode explanations are transparent, decision makers can trust the recommendations and translate them into practical business strategies. But before deploying this model in production, several additional steps should be considered. First, the model should be monitored regularly for performance, drift, and fairness changes. Second, automated pipelines should be implemented for the data updates and model retraining. Third, explainability dashboards such as SGAP visualizations should be integrated into business analytics systems so that managers can interpret predictions easily. In conclusion, this project demonstrates how machine learning can be used to predict customer churn while following responsible AI principles. We developed a high-performing XGBoost classifier, evaluated its reliability and fairness, and applied multiple explainability techniques, including SJP, PDP, and Align. These methods ensure that the model is not only accurate but also transparent, interpretable, and ethical responsible. Thank you for listening.